Okay, so we're going to move on, and this next section is about rotations. All right, so we're in section 2.3, and just so you know, the section that we're going to discuss, we're going to get homework, but it's not going to be due till Monday. We're going to take a little bit more time with this one. I think it's a little bit harder to visually see the rotations. The translations, I think, are pretty simple. The reflections are fairly easy. Rotations, though, can be a little more challenging. All right, so we're going to give ourselves at least 2 days to go over the rotations in this assignment. Okay? All right, so, again, we're still in transformations. On Tuesday, we did translations with vectors. And yesterday we did reflections. And today we're doing rotations. All right, so in your notes, some things before we even get to the book. In your notes, I want to discuss what rotations are. All right. All right. So first of all, when it talks about a rotation, there's one thing you have to be aware of is which direction is the figure being rotated. If it doesn't tell you specifically, then you want to think that it's being rotated counterclockwise. So if you think of counterclockwise rotation, unfortunately, for this discussion, technology has kind of ruled out a clock. I know in some classrooms you've got the old style clock, but if this is at 12, and this is at 3, and this is at 6, and this is at 9, if I go this way, that means I'm going clockwise. Okay? So if it's being rotated like a dial, like an old but like your locker, that's clockwise. If I go this way, that's counterclockwise. So you have to know the difference between and where those originate from on a clock, counterclockwise, clockwise. All right? So I think it's fairly obvious. If I go from 12 to 3, that means I've went 90 degrees. If I go from 12 to 6, that means I've went 180 degrees. If I go from 12 to 9, I've got to add another 90, that means I've went 270. And if I go all the way around to where I started, I went 360 degrees. Right? Okay, so stay with me here. What if I rotated something 1,080 degrees? How many rotations is that? 3 evenly? Yeah. Just divide it by 360, or you just think of 360, 720, and 180. So 3 rotations. Okay. Now let's do one that doesn't go into it evenly. What about 540? What do you think, Bo? Well, one rotation is 360. What do you think, Nicholas?
It would be one rotation and a quarter of one.
How much of one?
Basically, it would be 360 and 180.
Yeah. So 360 plus 180, so that would be 1.5 rotation. Okay. I mean, see how we're doing that? Okay, and usually when we're talking like this, they usually end in increments of 90. Okay? So, all right, let's see what else. Let me show you something on a graph with a rotation. Okay, so let's say that I have a point here, and I have just a simple triangle over here. Okay? And I want to rotate that 180 degrees. Okay? Now, well, let's rotate it 90 degrees first. Then we'll rotate it 180 degrees. Well, how you do that is you use your protractor and you connect the dot to, you have to make sure it lines up with the 180. I got my upside down. Let me see a little better. Does that line up right with the, there it is. Perfect. And so then I got to connect, okay, 90 degrees. So the 90 degree here is right here. I connected right here. So that looks like it's 90 degrees. Now the only other thing I have to do is make sure that the distance from this point to this point, which is 1, 2, 3, is the same. So 1, 2, 3. See, so now I'm moving it the same amount. So that would be I've just rotated it 90 degrees. If I'm going to rotate 180, I would just continue it on this line. 1, 2, 3. You get the idea? And so it's like a, again, it's like a dial, counterclockwise. Going this way. Okay, we're good? All right, let's open up the book. All right, in the book on page 90. Look at page 90. There are some rules for rotations. We've copied these into our notes a few times. We need to do that again. Rules for rotations. There are 4 rules. I want you to get those into your note, that chart. I'm going to write it up here as well. If you notice the 180 degrees, that looks like a double reflection. Negative x, negative y. $360 might be the easiest one we've done. But let me know when you get the rules written down, okay? right, thank you. Let's move along. He's just chilling out over there, Colby. All right, what do we want to do now? Okay, so when we think about rotations, you got to be able to vision in your head, make sure it's counterclockwise or clockwise. Okay, so you got to keep that straight first. All right, turn to page. We don't need to do that one on page 89, but let's go to the top of page 90, right above where you guys were writing, and look at number 5. You see where it says clockwise rotation of 125 around point Q? You guys see that? Try and do it at your seat. I'm going to do it up here, but try and do it at your seat. Yep, you need a protractor. All right, so I'm going to do my best to... Is that Q below the S? It sure looks like it, doesn't it? All right, so we'll say...
We'll find it's even.
You
No,
think?
it's even.
Is it? Let's check.
Yeah.
It's really close to even, isn't it? If it's not exactly. All right, so we'll go. Now, it's not on a grid. I'm just doing it on a grid just because that's what paper I have up. So don't think that you have to do it on a grid because you don't. All right, so now how do we do this? All right, well, I'm going to rotate this. I'm going to choose the nearest point. Let's go S. And go through Q. Okay. And now, what's my degree measure? 125? I'm going to go 125 degrees. And so this is kind of tricky using this thing. I got to put the dot right over. I got to make sure that that line matches up with 180 degrees. It looks pretty close. And then I go, well, that's 90 there. There's 100. Sometimes your protractors are big, and so then you really got to work. 120. This looks like to me 125 right there. That makes sense? So now I'm going to connect 125 to Q. I'm not done at all. That just gives me 125 degrees. Now I want to match up the length of SQ and put S. And if I had a ruler, that'd be about right, but I don't know, maybe about right here. Does that look about the same? Looks about the same to me. Approximate, it doesn't have to be exact, but that's the idea. Okay, so now they have it T and U. So if it's rotating 125 degrees clockwise, it means it's going this direction. Okay. So if S is here and U is there, that means U is going to be further over. Oh, probably about here. And T is about right in line. Close. You get the idea? And you can do it for all 3 points. So you could use 125 degrees, and I could do U to Q, and come up, and it should still be, so I could connect U and still find it to be 125. Mine is, let's see how close am I? It is. This is more challenging. I agree. My U is about I'm a little off because it shows it about 122. See what I mean? And because I just did it by eye. But you could do each point at 125 degrees to get it exactly right. All right, we good? Good with that? Okay, let's move on. Look at example B at the top of the next page. I honestly think the one that we're getting ready to talk about is even easier. Okay, so example B, top of next page, which is the top of page 91. We have triangle. Is it KLM? Yep. Triangle KLM and we are rotating it 180 degrees. So if it's 180 degrees, it doesn't matter if it's clockwise or counterclockwise because that's the same since it's half of 360. Right? So it does not matter how we describe that. All right, well, first of all, let's get the coordinates of K, L, and M. Okay? Kylie, can you get those for me? What's the coordinate of K? 2, -1. Okay, and what's the coordinate of L? Say it again. 4, -1, and M? 1, -4. Okay, thank you. All right, so there we go. Those are the three coordinates. I'm going to go ahead and plot these over here on my grid. Make sure I stay on the screen. I'll plot these. All right, 2, -1, 1, 2, -1, 4, -1, 1, 2, 3, 4, -1, and 1, -4. 1, 2, 3, 4. Okay, so there is KLM. Now, what quadrant is that in? You guys remember that? That's right, it's in quadrant 4. If I'm going to rotate 180 degrees, I should have an idea. I'm going to end up here, halfway around, which would be in quadrant 2. Okay? All right, so now I'm not going to use the protractor on this one. Now, I could have, because it says it's around the origin. So just like I did before, I could have used the origin and then did 180 degrees. I could do it graphically, but this time I'm going to use the rule and the coordinate. It's called coordinate notation. Okay, well, 180 degrees, the rule is x, y. You just wrote them down. It's the same thing as -x, -y. Remember, it's the same as a double reflection. Okay, you just wrote those rules down. Now we're going to apply those rules. Apply those rules. So I'm going to go K prime is -2, +1. We're just taking the opposite of each. L prime is -4, +1. And M prime is -1, +4. Now I'm going to plot those 3 points. -2, +1, -2, +1. There we go. That's K prime. -4, 1, 2, 3, 4, +1. That's L prime. And -1, +4, 1, 2, 3, 4. That's M prime. And we're done. Okay, that's all they want us to do in example B. So we're going, in this case, we're going that direction. Or, we could went that direction. But counterclockwise. All right, questions on example B? No? All right, go ahead at the next page, page 92. Do number 8. Do number 8. You want to do number 8 exactly like we just did. Use coordinate notation. Do number 8. If you're stuck, I'm going to do it as well. If you're not stuck, get working. Number 8, page 92. That tells you what rule to use. If it's 270 degrees, think back to the chart you just put down in your notes. That'll tell you what rule to use. Does that help?
Yeah.
So D is -3, +1. All right, so there's the original. Now I'm going to apply the rule. What's the rule for 270? Y negative x? Okay. There's my 4 new coordinates after applying the rule. I'll use a different color and graph these. Negative, no. 1, 3. -1, 1. -4, 1. And -3. Okay. .270 degrees. That's what it should look like. You got it? All right, so let's do a little bit of investigation. We said it's 270 degrees. If it goes 270 degrees this way, how much would it be going this way? What do you think, Bo?
No.
That's right. 360 minus 270. That make sense? Okay, so let's verify that. Watch that. You don't have to do this on your paper, but just watch. If I were to connect, because the origin is our center of rotation, if I were to connect, let's say we'll do D and D prime. If I were to connect D to the origin, make a nice long line here. So there's D to the origin, and I connect the origin to D prime. Make a nice long line. What angle should be formed by those? A 90-degree angle, right? It's because it depends on which way I'm going. It's 270 going one way, but it's 90 going the other. So look, let's see. Am I right on it? Right there. Boy, that is just a tad off. Does that look like it? Right there. 90 degrees. You guys see that all right? I know my compass is a little dirty. It had tape on it or something. I don't know what it was. But, okay. All right, good. Let's keep moving then. All right, what are we doing down here? Oh, yeah. What if we have this? Here's a scenario. I'm just going to call it an example. Okay.
This isn't in the book.
This is not in the book. This is just an example. I'm just using grid paper, but it doesn't have to be on grid paper. So let's just say I have a rectangle and another rectangle. Okay. How far did it rotate? And that's what we're trying to find. Okay? Well, in order to do that, you got to match up. You have to match up what I would say corresponding points or parts. Okay, so let's just say that this point right here matches to this point. Just for the sake of the example. All right? And so then all we do, something we've done a couple times now, we connect. We're just going to use our protractor and find the degree measure. And again, if your protractor is a little bigger, you have to expand your space a little bit. So if I'm going to do that, focus in so you guys can see it a little bit better. Help me out back there in the back, Jalen. What do you think? Am I on that circle? See this line here? It's kind of hard to see, but you see this line right there at 180? That line's got to match up on this line. Okay, so Jalen, from the back, tell me if I'm there or not. I've got a different angle, and I want you to be able to see it from the back. That's not matched up, is it? That doesn't look like it. Okay, come down. Right there. Jalen, does that look good? His friend, Mason, sorry. That's where Jalen said all year last year, my bad. Mason, sorry, from the back. Does that match up pretty good? Can you see it? All right, so then what you have to do is, where that connected, I didn't go out far enough, did I? So I'm going to go back and make this line a little longer. If your protractor is a little bigger, you might have to do that. All right, so let me come back here again. Mason. Sorry. Does that match up? Yeah. Okay. So then find right here, where is that? Okay, well, I've got two numbers where that is. It's either like between 60 and 70 or between 120 and 110. To me, that is about, what, 115? So from here, I know it's more than 90 just by looking at it. It's like 115 degrees. Okay? Because you're going to have to do that on the homework as well, figuring out what that measure is with the protractor. All right, go ahead and look at the next page, page 93. At the top of the page, see if you can find, using your protractor, see if you can find the degree measure. Page 93. Example B, at the top of the page.
So do you connect them to P?
Yeah, you always have to go to the center of rotation.
So I understand that the rotation would be that, but so what's the difference between a rotation and an angle measure? Nothing?
No, that is the rotation. All right, somebody have an angle measure? What do you think? Bo, want to try it? What do you think?
I got, it was either 155 exact or around
I couldn't hear you. One what?
around 155 exact or just around 155.
It's a little high. Might have the answer's actually less than that. What do you got, Chase? 135 is it? Exactly. Counterclockwise. All right, so that's your answer, counterclockwise. All right, go ahead at the bottom of the page and try to do number 11. Again, use your protractor, connect to this center of rotation. Carter, what'd you get? You get an answer? Oh. Micah, you got an answer?
70.
That is correct. 70 degrees.
I don't know. How do you measure angles with this thing?
Yeah, I'm confused on
You use a protractor?
Well, yeah, yours is like, I don't know if because yours is smaller or something, but I don't know how you measure this thing.
Okay, I can teach you. I just can't teach you. But if it's that's the case, then everyone's gonna be a little bit different. You know what I mean? I can look at yours and help you. All right. If you notice, the assignment is there, page 95, 2 through 12, 14, 17, and it is due on Monday. Okay. This will take you a little bit. Don't wait till Sunday night because you're going to get frustrated. All right? This will take you a little bit. Page 95, 2 through 12, 14, 17. It's due Monday class time.